Hi, in this video, we are looking at simultaneous equations. By the end of the video, you'll be able to determine if two lines intersect and if they do, at which point. Okay, so you're going to know, and you should already know, if lines are parallel. So in this situation, we're going to have no solutions. You're going to be able to determine if lines meet. That means you'll have one solution. And if the lines meet, you'll be able to find where using the method of substitution. We know that relations such as y equals 3x plus 2 make a line on a Cartesian plane. Sometimes we're going to have two lines on that same plane, or two relationships we want to compare. We're going to need to be able to find when they intersect or cross over, and this is called solving the pair of simultaneous equations. So in, say, a real world situation, not just like, mathematics class, we're going to have, that's a very bad line. Let's kind of pretend that that's a vertical line. There we go. It's a vertical line. And another line here. We're making a first quadrant Cartesian plane. We may have, say, a business who is making a profit, and they have some form of costs. Okay, we want to find out where they meet. Okay, so this is our income, and this is our costs. Okay, we want to find out where they meet. Okay, we're like right around here. You might be able to see my dots. Okay, beyond this point is the break even. Okay, so beyond this time, okay, they're making more money than they have spent. On the left hand side, they have spent more money than they have brought in. So that means that's our break even point, and we're going to look at this algebraically. Okay, so finding out the point at which they meet, you can obviously do it graphically, but today we're looking at the algebraic method of substitution. So there are two algebraic methods to solving simultaneous equations. We have the substitution, obviously, we're talking about already, and the elimination method. Okay, and we're going to focus on the substitution method. The substitution method is usually best when at least one of the equations has one pronumeral as the subject. Okay, so you're going to be shown more than one equation in this situation. So if we're looking at this example down here, we've got right here, in these two equations, we have y equals 3x plus 2 or x equals 3y minus 1. You can see that y is a subject in the first one and x is a subject in the second one. So in this situation, we could use either one of them as the subject. Okay, we can use either one of them substituting in. So let's have a look at example 1. This should be in your notes book. We're going to solve this pair of simultaneous equations. We have 2x minus 3y, and that equals -8, and then y equals x plus 3. The first thing we need to do when we come across a pair of equations and we're solving them simultaneously, I want you to just make a note somewhere that one is equation 1 and the other is equation 2. Now, in the equation 2, you should be able to see, and I might just erase this circle over here so you can see, in this equation 2, and I might just write it over here so we can see it later, we have y is the subject. So we know what y is equal to. Okay, we know what y is equal to. It is equal to x plus 3. On the other side, we have 2x minus 3y, and that is equal to -8. So -8 equals that stuff, and that's really meaningless to us. But we know that y is equal to x plus 3. So what we're going to do, we know that we're using substitution, but if you see y as a subject, you're just going to use substitution. So we're going to, just like a good programmer, we're going to write some notation here to instruct the reader. We're going to tell the reader what we're doing, okay? So it's, hey reader, we're going to sub is short for substitution. We're going to substitute equation 2 into equation 1. Okay. So as we see on this second side, on this equation 1, we're going to write equation 1 now, 2x minus 3y. But we know what y is equal to. Y is equal to x plus 3. So in a set of brackets, we're going to write x plus 3. And that equals negative 8. Okay. So we know what y is equal to. It's equal to x plus 3. So we're substituting it into that equation. Okay. So where does that go from here? Well, we now only have one pronumeral, one type of pronumeral. We have 2x and x. Okay, that's one type. Let's neaten this up and expand our brackets and simplify. Okay, so we end up with 2x. 2x stays the same. And let's expand this set of brackets here. So negative 3 times x is negative 3x. And negative 3 times 3, well, that's negative 9. And that equals negative 8. Okay. So we now have two like terms. We have 2x minus 3x. So 2x minus 3x is negative x. So negative 1x. And we only write the negative x. Minus 9 is equal to negative 8. Let's write an 8, please. We're not gonna. We're playing live here. So an 8. There we go. That looks a little bit better. Now we have our negative x minus 9. Well, we're solving for x, so we need to add 9 to both sides. And we have negative x and 1. And then negative x is equal to 1, so that means x is equal to negative 1. Now, some of you might turn around and go, okay, I can do this bit, but why are we solving for x? Why are we solving for x? Well, let's call back here. Up here, we need to find where they intersect. The lines intersect. The lines intersect at a point on the Cartesian plane. So we know that where they intersect is x equals negative 1. So I'm going to put a box around it. That's important. Okay, excuse me. There we go. All right, we're going to put a box around it. It's important. So we're looking for a coordinate point. So we know where the x value is, so we need to find out where the y value is. We can do that using either of these equations, but we're going to grab x equals negative 1, and we're going to let x equals negative 1, and we're going to put it into the second one. Now, you ask me, why did I choose a second equation? Because it looks a little bit easier to work with than equation 1. Okay, so you need to think about, which one's easier looking. I like the idea of just adding 3 to whatever my x is. Okay. And so we say let x equal negative 1 in equation 2. And I don't write x2, I write 2 with a circle around it because that's what I've labeled it as over here. So let x equals negative 1 in equation 2. So that is y equals negative 1 plus 3. So that means that y is equal to 2. So there are 3 ways that we could write out solutions, just like I have here, x equals negative 1 and y equals 2. Or we could write x equals negative 1 and y equals 2, and then put a box around them. At negative 1, 2. Okay, this is an okay kind of way of representing it, because you are looking for a point that the two lines intersect. Okay, so we can do this first one. This next one, we're going to get right into it. So if you feel confident, I want you to pause the video and have a go at solving this one. Oh my god, I can't find this spot. There we go. I want you to have a go at solving this one. Pause the video and come back to me in a minute. But because we have our the magic of the internet and the pause button, I'm going to keep going. Okay. So in example 2, we have y equals negative 3x plus 2 and y equals 7x minus 8. Now, in both of these equations, we can quickly identify that y is a subject for both. So we have equation 1 and equation 2, y is a subject for both of them. Okay, so y and y. So in this equation, y equals negative 3x plus 2. And in this equation, y equals 7x minus 8. So when the two lines meet, they're going to meet at the same y value. All right. So this is where I can just say, well, doesn't matter with the order for this one, 1 into 2. Sometimes the order does matter. I write this for the reader so that the reader can come back and see, oh, he's just doing this. Okay. He's putting 1 into 2. Okay. So, well, let's start writing. We have negative 3x plus 2. And that equals, well, the equal sign, we'll just move it on to the other side. But that equals this one, 7x minus 8. At the point that they're meeting, these two equations are what we call equivalent. They're the same, okay? So let's find out what the x value is. We can see that there's an x value here, okay? Let's get all our x values on one side, and I like to have my x values. I just want to have my x values at this point on the right-hand side. So I'm going to add 3x to both sides, plus 3x. And we have 2 equals 10x minus 8. Okay. 2 equals 10x minus 8. And then, well, let's get the x values all together and get rid of all this other stuff. So we need to add 8. So we've got 10 equals x. Well, let's scroll down slightly now that we can actually move down a little bit. Well, 10x doesn't 10 doesn't equal x. It's 10 equals 10x. So x, let's divide by 10. Divide by 10. X is equal to 1. Okay, 10 divided by x. And we could have written it around the other way. It doesn't matter. I use my mathematical knowledge to write x equals on the other side. All right, now we can just substitute x equals 1 into one of these two. Now, I like equation 1 this time. Okay, we can do equation 2 if you want, but I'm going to do equation 1. We do let x equal 1 in, and I said equation 1. Let's do equation 1. So that means y equals negative 3 outside of 1 plus 2. So y equals negative 3 plus 2. And negative 3 plus 2 is negative 1. Y equals negative 1. Now we can put our box around this one and put our box around here. I'll run out of space. Okay. So, or we can write y equals negative 1 and x equals 1 here. Order doesn't matter when you're writing it. Generally, we like to have the x first. Or you, once again, you can write 1 comma negative 1. This is okay. We can write it like this, okay, because we are identifying a point. But I generally prefer the box off to the right-hand side here, okay? And there we are. We're done. You should be able to determine if lines are parallel, and that's by finding lines that have the same gradient. You should be able to determine if lines meet with the one solution and calculate the point at which the two lines meet using the substitution method.